good. No pop quizzes.
No pop quizzes.
Anyway. So thank you all for coming. My name is Rafi Gashidorian, and today I will be doing a very first lesson on Introduction to Objective-C with the focus of having people familiar with Java as the audience. And if you're only familiar with Scala, hopefully if you have any questions, feel free to stop me along the way, and we can help you out. Oh, it's dual projector. Okay, cool. So yeah, like I said, if you have any questions, feel free to stop me at any time. This talk is inspired by the book Learn Objective-C for Java Developers by James Buckeneck of A-Press 2009. It's a good book. I highly recommend it if you're interested in the topic. And also feel free to come to me after class. So I'm expecting a few things as a background. One is a basic familiarity with object-oriented programming concepts. And since this talk is focused on how to relate Objective-C concepts to Java, I am expecting a little bit of how these concepts are manifested in Java. However, if you know at least one object-oriented programming language, they should be pretty transferable. So why do I think this topic is important? Well, Objective-C is the language typically used to write native software for Mac. So it's one platform that this language is used usually. And Mac is not the typical computer used in all households, but it's gaining some ground. And according to Gartner, there was a 28.5% increase in home Mac sales just last year. So that's one motivation. And what do I mean by native? Any ideas about native software? What's the difference between native and non-native software? Yes?
Something to do with whether or not it's on a network?
Not quite. No.
Okay.
That's a good
Well,
try.
I tried.
Yeah, definitely a good try. Yes?
Is it software that comes pre-installed with the operating system?
Oh, software, that is a good point. Yep, you would expect software that comes pre-installed with the operating system to be native. However, I think, at least on Mac, that Java is actually, well, no, all right, so Java would be native as far as the virtual machine. That's typically the truth, that native software does, come installed pre-installed. That's a very good point. But you can also have software that's native to the system that you're working on that was not pre-installed. Like we can make one today, for example. And I actually have a demo if we have time. So that's a very good try. Thank you. So if you're not familiar with the term native, it means that the machine instructions that are produced by the compiler when you write your program are directly for that machine. So this is opposed to a language where there's either a virtual machine present that translates the intermediate representation, like a bytecode, like in Java, for example, to a language-specific machine code is specific to the particular platform you're on, or an interpreted language. So does anyone have an example of an interpreted language? Can you think of one that does not need a compiler? Starts with a J.
Yeah, the one you're learning, yeah.
Kind of looks like this.
It's not a component. You learned it in your first class here.
Yeah.
It's not with a J, it's a different one.
Yeah, the only language you learned with a J.
Oh, we're actually saying in Java.
Right.
Oh yeah,
Yeah.
right. It's a partially compiled, partially interpreted language, right? So the interpreter actually is the virtual machine that you write. When you say Java, your program, that's the interpreter part of Java. Java-C, the compiler, is the compiler part that makes not machine code, but intermediate representation that gets interpreted by the virtual machine. Another example is Python, which does not need the compiler. PHP is another example. So native software, unlike, say, Java software, is non-cross-platform, so it's for one particular system. And what this buys you usually is you get a native look and feel of the system you're working on. For example, you would get a Mac UI look and feel. This is a Keynote application for Mac. Your software will look a little bit like Keynote. If you've ever used a Mac before, a lot of the software looks very similar. Also, it behaves similarly, which is nice for the users of the system because they're comfortable with the environment, the interface, etc. So, any examples of non-native languages? Can anyone think of one? What's a language? I guess we went through this already, but a language that you can write once and use anywhere.
It's
HTML language? I don't
Well, yeah, HTML is a declarative language. Yeah, I think that counts. So HTML is an example, right? Python is an example of PHP. These are different cross-platform languages. Okay, another reason is that Objective-C is the language used to write native software for iOS. So native here in iOS setting is that, well, iOS is actually a very closed system. And iOS, of course, is very popular. There is a way to write non-native software for iOS. Does anyone know how that can be accomplished? Or very non-native-esque software? I'm trying to think of an app that does this. Facebook used to do this. Basically, the Facebook application on iOS was a very thin wrapper over an HTML browser. And so what I meant here about native software is not browser-based. So for example, JavaScript would be one example how you can write non-native software for iOS. Okay, so brief overview of what we're going to be covering today. So we're talking about Objective-C basics, how Objective-C is similar to Java, how it's different from Java. This talk is not directly, or this class session I should say, is not directly about iOS development in particular, but the topics can certainly be applied to at least beginning iOS development. We won't do any user interface stuff in this session, in other sessions. Okay, so let's talk a little bit about Objective-C and Java. So Objective-C is a high-level, object-oriented language. What do I mean by high-level? Any guesses on the high-level language?
It's not machine code.
It's not machine code. Yes, thank you. Anyone else want to add? Yes.
There's a lot of abstraction.
Yes, that's correct. Very good. A lot of abstraction. What do I mean by object-oriented? What makes a language object-oriented?
There's objects.
Right, there's objects. We also, yes, there's objects, and you want to think of, behaviors of these objects as opposed to like procedural language, where you think about tasks, for example. So, very good. Objective-C has its roots in a language called Smalltalk, which is a bit older object-oriented language, and the conceptualization of Objective-C that has its roots in Smalltalk is that you have basically a bunch of objects sitting around, communicating with each other, sending messages and receiving messages, and actually these constructs are pretty well manifested in Objective-C to solve a task collaboratively. Objective-C is also a strict superset of C, and I like to say it's a superset of C with a lot of Twitter. There's a lot of @ symbols, so if you're familiar with Twitter, you'll feel right at home with Objective-C. Objective-C is also strongly typed, like Java, but it has many dynamic features. And when I mean strongly typed, I mean that it's very structured. It can be very structured. So for example, in Java, what must you always write to the left of a variable? If you want to declare a variable, what goes immediately to the left of it? Categorically. Yes?
Data type?
A data type, yes, exactly, right. All variables are typed, all parameters are typed, functions are typed, right, because they're return types. You have the option not to do this in Objective-C. So Objective-C is nice in the sense that it gives you the flexibility to be very structured, and it gives you also the flexibility to be very unstructured and have a lot of dynamism in your software language, in your programming language. This can also be done with Java using the reflection API, but it's a little more cumbersome. So one thing Objective-C buys you is nice language support to do this. We'll talk about a little bit about this more later. Both languages require a compiler. The LLVM is a popular Objective-C compiler. The language is multi-platform, which means that you can use it to write not only Mac and iOS applications, but also, let's say, a Linux application. However, a lot of the popular libraries for Objective-C are not cross-platform, and one example is called the Cocoa libraries. And if you're on iOS, it's called Cocoa Touch. These libraries are very similar to the frameworks in the JDK, if you're familiar with Java. Okay, main differences with Java. Why would I want to use Objective-C as opposed to Java? This is kind of a controversial topic, but Objective-C is fast. That's a very vague statement. Why might say that Objective-C is fast? Well, since it's a superset of C, C is one of the most fast high-level languages available to us, besides assembly code, which is a low-level language. But people that want to write fast software usually pick C. Like, for example, your operating system's mostly in C. Real-time software mostly in C or in a combination or assembly. So in that sense, you can write C right into your Objective-C code. You can interface with assembly languages. So you have the option for speed there. You can also do this in Java. You can interface with C with Java using something called the JNI, Java Native Interface. But you don't have the overhead in Objective-C with the virtual machine, going down to the machine level. So it's directly to the machine. Objective-C is dynamic, as I mentioned a little bit before. So you can have a lot of things that are untyped or unstructured in Objective-C. And it makes it very similar to scripting languages like Python or PHP. And what happens is that many decisions are left to runtime. And what this allows you to do as an Objective-C developer is to, at runtime, alter the behavior of your objects, of your classes. You can attach methods to your classes that you didn't write when you wrote the program before you compiled it. And you'll see this with a lot of different Objective-C features. There's one in particular called categories. I won't get into in the talk in time for this lecture. But what categories allow you to do is to add methods to, let's say, classes you didn't write at runtime, if you like. So for example, if you're thinking about Java, you have a Java lang string, right? You can make your own method for string and attach it to the Java string class. So if you have an API that returns, let's say, a string, that string can have your own method in Objective-C. It's really nice. It has actually some flavors of aspect-oriented programming, if you're familiar with that. The syntax is very different with Objective-C, especially in method invocation. We'll take a look at that. And probably one of the biggest differences between Java and Objective-C is that the memory management model. There is no garbage collection in Objective-C. Instead, there's something called ownership types and automated reference counting, and I'll get more into that later. But we'll see that's something you have to keep in mind as an Objective-C developer, that there is no runtime system that is keeping track of your memory allocations and sweeping up any quote-unquote garbage that you may have over. So we'll talk about that momentarily. All right, a little brief history about Objective-C. It began as a way to add object-oriented programming to C. Can anyone think of any other language that tried to do this or has done this?
C++.
Yes, C++, great. Right, so Objective-C is another way to add objects to C. It was driven by Brad Cox and Tim Love in 1986, so it's been around for quite a bit. It was adopted by Next and used in a next step operating system. It had fierce competition with C++, so it wasn't very popular for a very long time. But in 1996, a company called Apple purchased Next and released subsequently Mac OS X. Anything special happened in 1996 that would allow for that event? Initials are SJ.
I was going to say that.
I quit a job in
I was
96.
going to say Steve Jobs.
Yep, right. Next was Steve Jobs' company.
Bingo, John.
Yeah.
Steve Jobs went back to Apple as a CEO. One of his first things he did was conveniently buy his old company. So that's the history behind Objective-C. Okay, let's go right into an example. So here I have an example of class declaration. It's a student class, so maybe you guys can relate to it. And this is the whole class. And what I'm going to do is I'm going to go through each part of the declaration of this class, and we're going to dissect it. So I'm going to start with the very first line here, which is a comment. So here I have the file name, which is called student.h. So in Java, normally your classes reside in how many files? How many files does it take to write one class usually? Just one, right. That's not the case in C development. Consequently, it's not the case in Objective-C. So in Objective-C and C and C++, classes are normally split into two different files. One is called a header, and that's prefixed with a .h extension. And the other one is called an implementation file. That's prefixed with a .m extension. And that contains the class definition. So you have the header file, which contains the class, contains the class declaration. The implementation file, the .m file, contains the class definition. Does anyone have an idea what this sounds like in Java? Is there any similar concepts in Java to this scheme? Starts with an I.
Interface?
Interface, yes, great. Yeah, it's sort of like an interface. Confusingly, there is another concept of interfaces in Objective-C called protocols. I won't be getting to those in this lecture. But just note here that it's a very similar notion of something called abstraction, right? You're abstracting away details of the class so that clients or programmers of the class can't depend on these. And that's exactly what my next bullet says. So when you're giving clients of your class the ability to use your class, you give them the header file and the object file, which would be like the .class file in Java, but not the .m file, because you don't want, again, want them to depend on the internals of the class. And this is for the notions of information hiding, abstractions, which are similar to the ones in Java. All right, next one is the import statement. So here, pound importing something called foundation/foundation.h. Is this similar to anything in Java? All right, the import statement, right? It's quite similar to the import statement in Java. There's a few important differences. So one difference is that you must have the header file being imported into your class. So it's not enough to just have the class name. So actually, foundation.h is like the umbrella framework for the Cocoa libraries. In fact, if you open up this file, you'll find a number of other pound import statements. It's processed by the pre-compiler. So there's a part of the compiler that processes your program before it sends to the main compiler. And what that does is takes code from your pound import statements and puts them into this file at compile time. So that way the compiler can process the entire set of code. And by the way, also, the compiler must know where these header files are. So there is no class path in Objective-C. There's different ways to configure the compiler to tell it where to find these files. You can usually do that something called the Xcode project configuration. And Xcode is the IDE, the integrated development environment, usually used to write Objective-C software. And there's different ways to go about that. But this is a system class, and the way I know that is that it's we use these brackets for our own, and we'll see this later, for our own header files, we use the quotes. So for the system ones, the compiler already knows where to find that code. Okay, like I said before, you must specify a header file for a framework or library, and not just a class name, or a star. So that's one difference with Java. All right, next we have the @ interface. So if you have not noticed but until now, these @ signs denote keywords in Objective-C. You're also in purple. So here is my @ interface of a class called student. The interface specifies the following. So one is the class name, which is student here. It also specifies information about the class. So here I'm saying that student extends something called NSObject, which is another class. NSObject is very similar to the Java lang object, right? The superclass of all classes in Java. That's not necessarily true in Objective-C. There is something actually called object in Objective-C, but it's very low level and we don't use it very often. But for all intents and purposes, you can think of NSObject as being like the superclass of all Objective-C objects, or classes rather. Does anyone know what the NS stands for?
I'm going to guess next step.
Yes, next up, right. You referred to it last slide too, great. So that's another thing to think about. I'll mention that in a couple of minutes. One thing to note is that inheritance in Objective-C works very much like it does in Java. There's no multiple inheritance, unlike C++. Inside the body of the interface, and actually @n, which delimits the class declaration, you can place instance variables, methods, and something called properties, which we'll get to in the next slide. and limited by end, which is another Objective-C keyword. All right, so notice that there's no package declaration. So that's a key difference with Java. So in Objective-C, there's something called namespace. Actually, well, there's something in C++, actually, there's something called namespace. But more generically, there are no namespaces in Objective-C. There's no concept of packages. If you're familiar with C++, there's no concept of namespaces. So, and this is how it's done in C. There's no packages in C. Also, Objective-C is a strict superset of C. Hence, there are no packages in Objective-C as well. And to combat this, what we use usually are prefixes for our classes. So, for example, if we're working at Facebook, we might name this FB student. I'm going to keep it as student just for simplicity of the lecture. And you might think this is kind of cumbersome, but actually in your Xcode project, you can specify a prefix for all classes that you can create. So every time you create a new class in your IDE, in your integrated development environment, it will prefix it for you. It's not too bad, but keep that in mind. Okay, so now class properties. So I have a new property here. It's called first name. So what's a property? Well, a property is a way for clients to indirectly access instance variables. Can anyone tell me the analogus to this in Java? How can we indirectly access instance variables in Java? Yes?
Would be a getter.
Yes, right. Getter, and to mutate them, we would use something like a setter, right? You can also do this in Objective-C, but there's language support in Objective-C to actually create these getters and setters for you. Why don't I just have public instance variables? Why do I even need a way to indirectly access data of my class? Why bother? Why can't I just make everything public and say, here, go for it? Yes?
You don't want other classes to modify them?
You don't want, well, if you use a setter, right, you can have someone modify it, right?
Only ones that you want to control.
Yes, control, right. You can control the way they're modified. You can control which ones are modified, right? You can keep ones for your internal use. So again, this is part of information hiding abstraction. Clients don't depend on the internals of your class because, let's say, I have a list of grades in here for my student, and they want to, today I have them as a linked list. Tomorrow I want them as an array. So I don't want clients to depend on the internals, the specifics of the class I use there. Great. So your properties can be read-write, which means that the compiler will generate a getter or a setter for you, or it can be read-only, which means that the compiler will generate only a getter, an accessor, right, a method for your class. So when you use the add property keyword, the compiler synthesizes, which is another way to say it generates code for your class, for the accessor or mutator method, or getter and setter, based on something called property attributes. So here I have a property attribute called copy. What does that mean? That means provide clients, right, users of my class, which means other programmers or yourself, with a copy of first name. Why would I want to provide clients of my class a copy of first name? Why not just give them a direct reference to the instance variable? Great memory question. Memory management question. It's kind of a trick question. So what happens, so copy is not the default of my property attribute. So I can leave it out and it will actually provide a reference to the first name, right, instance variable in my class. So clients that instantiate objects of class student will receive direct access, right, to the first name instance variable. Why could that be bad?
Is this access just read-only, or direct access is read and write?
Right, read and write. It's direct access.
It's the same answer that Wes gave before then.
Slightly different. The reason is that there could be multiple references to to this variable, right? And then let's say one client changes it, that will change or propagate to the rest. And maybe not on purpose, I don't know.
So you don't put this copy and you make a property, this means you provide setters and getters, you still get a reference to the code.
Right.
Reference, which means reference to the memory, so they can.
Reference to the memory,
modify it.
yes.
Yeah,
Right.
so it's, because it's C++ guys, C, memory references, so you could look into the memory.
Right, you can look at the memory, right, but it's really a trick question because in Java, strings are immutable, right? You have a string, once you instantiate a string, you can never change it. So in fact, if this was Java, giving them direct reference, right, to first name here actually would not be bad because they can't change it, right? So we can guarantee that multiple clients that share, have a reference to this first name instance variable are receiving consistent copies, right, of that variable. However, that's not necessarily true in Objective-C. So Objective-C, the normal string class, which I'll point out in a second here, is immutable, but like a lot of Objective-C types, there are mutable versions, subclasses of that class. So in fact, Objective-C has a mutable string class called mutable string, NS mutable string, that you can modify. So it's not necessarily true that every string in Objective-C is immutable. There are other property attributes that you can use for the compiler to generate your accessor and mutator methods. You could also use something strong and weak. We'll get to that when we talk about memory management. Furthermore, you can declare properties and actually not have the compiler generate the corresponding methods for you. You can do it yourself. It's actually very easy to do this. You just write the method in the implementation file. We'll see that momentarily as well.
So the declaration in the H file will automatically generate code in the .m file, right?
Well, it won't be in the .m file, but it will be in the
really?
object file. Yeah.
Ooh, cool.
So yeah, you don't get the source code. The compiler will generate it for you when it does the
So
object code.
you don't have.
You never
the
see
M?
it, right? You don't have
There's
to
no .m file at all.
well, yeah, you can have
Yeah.
a situation where we have one here because
Oh,
I have
okay.
something called a derived property. But yeah, it's possible. You don't have to have one because you can have the compiler generate all the code. So, and by the way, NS star means a string reference. So NS string is the string class for Objective-C. It's very similar to string first name in Java. The star means reference. So let's talk about memory management. And so one of the main differences between Objective-C and Java. So as I mentioned before, there's no garbage collection in Objective-C. Why? Actually, it's a little bit of a trick question too, because there was a garbage collection in Objective-C. It was only for Mac. They got rid of it. There was never garbage collection for iOS. Why would I, if I'm a language designer, why would I not want to include garbage collection in my runtime? Doesn't everyone love to have their garbage collected for them? I do.
But it's slow.
It's slow, right? So what happens with garbage collection is that the JVM stops at some given point. It says, okay, time to clean up my garbage. I gotta look at all the other objects, in my my runtime and see which ones have no references to them anymore, and deallocate all the memory. So if you think of something like a server application that's running 24/7, thousands of clients connected to it, this could be slow. So what Objective-C does, it gives you something called automated reference counting. And I claim this is faster. It's also controversial. But conceptually, we'll see that it is a bit faster. Because there's no stopping of the clock, there's no stopping the program to do a sweep of your garbage. And reference counting means that each object is associated with a count of other objects that refer to it. And I'll talk about how Objective-C uses that to know when to deallocate objects. There's two types of references in Objective-C. There's something called a weak reference, and there's something called a strong reference. And this has very much to do with the way ownership is conceptualized in Objective-C. So there's a very strong concept, well, strong is the wrong word here, but there's a concept of objects owning other objects. And then owning them in a weak way and a strong way. When an object has a weak reference to another object, it says, I need to refer to this object, but I don't own it. It's not part of me. I just kind of use it. If an object has a strong reference, that means I am one of the owners. right? And I underline and there because there could be multiple owners of an object. And this really tells Objective-C how and when to deallocate your memory. So the rule is this. Objects are deallocated when no strong references to them remain. So when the reference count of strong references to an object is 0, that means that Objective-C can immediately deallocate that object, which means that you don't need to stop the entire system. The allocation can happen right away. There's some caveats here, or consequences. That means an object with only weak references may be deallocated. So when you have an owning relationship that some object weakly owns another object, that object may no longer be around. It's gone. It's deallocated. That memory has been thrown back to the pool for other objects to use. One thing to note here is that there's a feature in Objective-C that when this happens, the reference to that object, the ones that were deallocated, are set to null. Or nil, actually, in Objective-C. So nil is a keyword that's very similar to null in Java. So now let's say I have a weak reference to an object, and now I call a method on it. So if I have a null reference in Java, and I call a method on a null reference, what happens? Yeah, crashes, right? Well, it doesn't crash. It throws an exception, right? Null pointer exception. That's not the case in Objective-C. Nil references in Objective-C, when they receive a message, which is the equivalent of a method invocation in Java, the net effect is 0. Nothing happens. So,
Not so cool, I guess.
yeah, it's interesting because you may or may not want that, right? Of course, now you can simulate the way Java does it. You can say, oh, if null, throw. You can also throw exceptions in Objective-C. So,
But you wouldn't know if there is gonna be a problem that's gonna cause
Right.
exception.
it won't tell you, right? You'll be sending messages or invoking methods on a nil object or null object, right? And not know it. So you can do a check if you want. You can say if it's null.
And maybe,
Yeah, do something.
maybe it's good because you're conscious of
It could
all
be
your
good too.
references,
Yeah,
because
yeah.
You have to error check for each and every reference you're using. So it puts you in a mode of counting your references, making sure that everything's, which is very common in C++ too. Which I like.
Oh, good.
I don't mind.
Well, you may or may not. You have the option. So if you don't care if a message is object is null or deallocated, and you send a message to it, nothing happens. That's okay for you. For example, I can think of one pattern called observer, where changes to a subject object are propagated, or there's a bunch of notifications that go out to other objects. If that object is deallocated, that's okay. It just doesn't receive the notification. So it's like I call you and you're not home. I'll leave a message or something. So it might be okay. If it's not okay, then you can go ahead and take action.
Yeah, I should making sure before you like call me, making sure I'm home. He's better.
Right, but you have an answering machine, so I don't need to make sure, right? I can just call you, right? So it's up to you. It depends on the domain. So it can be good or bad depending on how you look at it. So question, ARC, which stands for Automated Reference Counting, Automatic Reference Counting, is that the same as garbage collection? Also funny that these two pictures are taken in St. Louis. How that happened, but so the answer is not exactly. You need to specify, right, as part of your property attributes, ownership. Do I weakly own this object, or do I strongly own this object? And another thing to worry about is something called retain cycles. Very nasty. I'll show you an example. Suppose you have an object, say O1, and O1 refers to, strongly, an object called O2. O2, in turn, strongly refers to object O1. Remember the rule. Objects are deallocated when no strong references to them remain. So when will O1 and O2 be deallocated? Never. Right. This is called a leak in Objective-C. Well, it's called a leak in any language, but so you have a leak situation where these objects will never be deallocated, which is fine if they're always being used. But if they're not being used, then you want them to be deallocated so that their memory is available to other objects. And if you're working with a system that has very low memory, this is important.
You want to add that I mean, what's good about C and C++ is, and C objective is being very memory aware. You're always developing with the memory and the type language where you worry about, oh, it's a double, maybe that's too big, maybe I have to make it an end. You're very memory aware, which is good, right?
It gives you at least some notion of memory that you need to figure
Yeah,
out.
and
Just
you're
listen to
kind
how
of,
it works.
you understand that you're always coding for a hardware. So you have to be aware of the memory of the hardware versus just coding, which is, I mean, you're talking to this machine, so you have to be aware of. And seeing the memory dumps is great.
True. Yeah, that's definitely, it depends on, of course, like what system you're working on. If you're working on a very, small embedded system, it doesn't have a lot of memory, you want to keep, like, memory in mind. So I have another slide here. Let me do this one more time. All right, suppose we have this situation now. So we have O1 strongly refers to O2, O2 strongly refers to O3, and O3 strongly refers to O1. So it's not always trivial to decide that you have a retained cycle. It could be a chain. So my question for homework for you guys for extra credit is, are there any tools that can tell you or make you aware of retained cycles in Objective-C? So if you give it to me at the beginning of next class or email me before next class, I'll give you extra credit if you have the right answer. So find me some tools that can detect retained cycles at compile time, before you run your program. All right, so now here you have an example going back to our student class of something called a derived property. So this is a property that does not have a corresponding instance variable behind it, so to speak. This is called full name. As you can imagine, it's a composition of first and last name with a space between. So I declared this derived property. Notice that the syntax is the same, right? I still used add property. To be read-only. And what's going to happen is that I'm going to write a method in my implementation file that derives this property from first and last name. And it's read-only because you can use this. You can use the mutator methods, right, for first and last name if you want to if clients want to mutate them. I also made this property non-atomic. So if you're wondering, the atomic keyword is very similar to synchronized in Java. And in fact, atomic is a default. So had I left non-atomic out here, atomic would be the default property attribute for this derived property. Why would I want to make this atomic? Yes?
What is synchronized in Java? I'm not familiar with that.
Oh, okay. So synchronized, So when you have multiple threads of execution, maybe I'm reaching. Okay. So all right, so remember how I said that clients can access your objects, right? So pretend that your program splits in parts. It duplicates itself, right? And now imagine that clients access objects, the same object at once, at the same time. Maybe over a network. You can think of it that way. That's not what I mean here by synchronization, but you can think of like maybe, there's a bunch of computers in a room, each have objects on them, and there's one main object, and they can access the object at the same time, potentially, simultaneously. So in Java, you can make methods called, you can mark them as synchronized, which means that it prevents a situation where a method is called for multiple objects at the same time. So there's an order. So if two objects say, okay, invoke this method on this one on the main object at the same time, one has to go after another. So the first one completes, then the second one goes. It's not like the first one executes one statement, the second one executes another statement, and they interleave. So they're separate. Great question. Great question. Okay, so admittedly, I made this non-atomic for simplicity of the implementation. But the reason you would want to have this atomic is that first and last name could change. If you have a situation where multiple objects are simultaneously calling this method, by the time the first name's outputted, the last name could have changed, so you could have a combination of one, a first name at one point and the last name at another point. But we'll see. I made this non-atomic for simplicity. So, but in real life, you would want this atomic.
sorry.
Sure.
How common is concurrent application development in Objective-C? So how common do you really use it?
It's quite common. Yeah, because they use a lot of GUI, right? A lot of GUI
Right.
components. A lot of things happen at the same time.
Yeah,
So
but in Java, it's sort of hidden. You really don't see.
It can be hidden- it can be hidden
yeah,
also
we
in
do
Objective-C.
the events and you have no idea. But here, do you really have to make threads and develop like?
No, there's actually language support for just forking threads. There's something actually it's a little bit out of scope of this talk, but there's something called perform selector in background,
Okay.
and selector means method, invoke this method in the background, and that automatically forks a thread.
Mhm.
That's a little bit outside the talk, of the focus of this lecture, but maybe in week 10 we'll get to that.
Okay. We can.
Okay, so here I have some more examples of properties. Here's an integer property called age, just to give you some more examples. Here is a Boolean property called enrolled, so whether or not the student is enrolled in courses. Here you notice that the bool keyword is a little different than Java, it's on all caps. And also, I'm specifying the name of the setter to make it more readable. I'm going to call the, actually this is the getter, the accessor method. I'm calling it is enrolled. So we can change the name of the accessor using the getter equals syntax there. All right, the student class definition. So this is in the .m file. So here's the whole file once again, and we'll step through it. So as I mentioned before, implementation files have a .m extension. Usually they're the same name, the same as the class name. There's some situations where that's not true, but for the most part they're the same. The first thing you want to do is pound import your header file. So the preprocessor will include that file or import it into this code before it compiles it and make sure that all the signatures match up. And then we go ahead and write our class definition. Notice that at implementation, right, keyword, our student class name, and in between the at implementation and at end, we'll write our definition. And it turns out there's only one method we need to write because the compiler is generating the other ones for us, and that's the derived property called full name. So this will be our method definition for the derived property. It's read-only, right? There's no mutator method, so we don't need to write that. The minus sign here means it's an instance method. Does not mean it's private. In fact, it's a public method. There's another way to write public and private methods in Objective-C, which I won't cover. But the minus means instance methods. Can anyone guess what a class method or a static method would be? The symbol for that? Plus, yes, great, thank you. Good guess. All right, full name here is our method name. Our return type is in parentheses. So ns string star means we're returning a reference to ns string. And here's the body of our method. Wow, looks really crazy.
Yeah. Oh my god.
So note that the method invocation is between the brackets. So in fact, our first, I'm going to like shadow it here, but the first method invocation, actually there's a few of them in here, is the outside brackets. So what we're doing here is actually calling a method called string with format, which happens to be a class method of the NSString class. And it's very similar to the Java output stream.format, if you're familiar with that function in Java. And here also the @ symbol means that it's an object reference. Again, NSString is a class, right? This is a class method. And in Objective-C, for all Objective-C strings, literals, right, that we write in quotes, we need to prefix them with the @ symbol, which means this is not a normal C string, but in fact it's an NS string, object reference. This symbol is also used to format the arguments. So here I'm saying ampersand, percent sign, percent sign at, which means that print is two strings I'm going to follow next with a comma here. And those are the two arguments here. So this, in fact, is my argument list. And what I'm doing here is actually, right, calling this method, right, string with format is method name. I'm calling the properties, right, the accessor methods, the first name and last name. Self is like this. in Java. And first name and last name are the properties. So what I'm doing here is I'm actually using these properties that I publicly made for clients in my class within my class. And the reason that's good is for abstraction and polymorphism. So if you're deriving a new class, those will actually go to the base, the derived classes of your own class.
And the spaces are all part of syntax,
The spaces are actually optional.
right? Optional?
Yeah. It's much like Java that it's white space insensitive.
And the first add after the string with format, so
Mhm.
string with format, name of the method, colon, you call them, you start putting your parameters,
So after the colon is your argument list.
argument list, yeah.
Right. So that means that this is an objective C string. That's what the first
The add
Add sign.
means it's an objective.
objective C string, as opposed to a normal string,
Oh.
like a C string. Great question. But we will cover more of this in subsequent classes. This is just a very quick introduction.
And square brackets, so.
Right, square brackets, right. The square brackets denote method invocation, much like the dot syntax in Java.
And the name, and you said full name is the name of the method?
Full name is your derived property. It's a property name.
Yeah, but if I make an object of student and try to call
Oh, yeah,
this
we
code,
can show,
how do
yeah.
I do it?
So next time, if we have time, I have a client demo. I
don't
can
know,
show you real quick.
Do we have that? Guess we have a couple minutes.
Yeah, okay, all right, great. So let me break out of this. Turn on my mirroring. Okay, let me show you that. I was practicing last night. And I forgot to erase it. All right, there we go. All right, so here I have, I'll get rid of that too. Pretend you didn't see that. So here is my Xcode IDE. I love how that all those forks in new window there. But here's our student class that we showed previously, and I'll give you a little zoom in here. So same exact copy there. Let me go back here. Here's my implementation file, right? Exactly from the talk, or from the lecture notes, I should say. There's another function here I wrote called description, which is similar to toString in Java. We'll go to that later. But basically, if you're looking at here for the full name method, that's exactly the same one without the spaces from the lecture notes. All right, so here is my main function. There's something called @auto_release_pool. We'll get to that in subsequent classes, but just note for now that it's just something that you need. We'll talk about how that works in later classes. So let me declare a student. So it's going to be very much like Java here. You declare the type, but one difference is you have a reference to the type. So like Java, Objective-C objects can only be referred to. They can't be valued, unlike C++, for example. I'll call this student in lowercase as my variable name. And the way to instantiate, one way to instantiate a class in Objective-C is to call a class method on the class, and the method name is called new. So right now it's telling me that student is unused. That's okay. So there I have a new student object. I can, oops, sorry about that. I can invoke methods on student. So I give student here, let's say I'll set first name. I'll give it a string. So Xcode is telling me here to provide a string reference. Sorry about that. I'll call this one Brett. So note here the @ sign, which means Objective-C string, as opposed to a C string, if you're familiar with C. And then the close brackets, Xcode is very nice enough to give me the bracket here for free. I'll call another method called setLastName. If I can spell for it. And I'll call a third method here called setAge. I'll say he's 100 years old. That's not true. Well, if you look, let's look at our student class real quick, just for comparison. So notice here that I called these set methods, right? I don't know why I keep doing that, but I call these set methods here. But there are no such methods in my declaration class. right? My class type relation rather. They're just properties, right? First name and last name, right? But the compiler provides me with the set first name, set last name methods. And the way that happens is from the syntax generation, from these properties. Any questions? Okay, so I'm going to stop doing the tabs. All right, so let's do this. Let's do something called NSLog, which is an output statement in Objective-C. Notice that it's not between the bracket notation. This is actually a C method, C-style method. And I'm going to say, can't even see that. So let's say student first name, and then I'll give it a format string here. So %sign means format. The next object reference I'm going to give you, which will be student first name. So this is not a direct reference to student, the first name, the instance variable student, but it is actually an accessor method. So let's run that. And you notice here that NSLog actually gives me a nice little output statement here. It has a date, has a time, my project name. And here it says student name, first name is Brett. Let's also call the derive property. So I'll say student full name. Right, similar syntax. And I'll say here student full name. All right, let's run that guy. And here's our output, Brett Favre. But now notice that there's actually like a code definition lookup in Xcode. So I can hold the command symbol down here, and these actually become links now. So if I press the first name here, it should take me to the definition of the first name. It takes me to the .h file, the header file, right? This property. Let's go back. Let's go to the definition of full name. That took me to the .m file. Isn't that cool? So the compiler is automatically generating the first accessor method, but it's using our own implementation of full method. And there's also the toString one that we can use as well. But I'll stop for time. So, any questions? No? Okay, that's our client demo. Let's go start this baby up again. So in conclusion, both Objective-C and Java are high-level, object-oriented compiled languages. Objective-C is not cross-platform, but it can be faster than Java because there's no garbage collection and other things. It's direct access to the machine. Java is very structured, while Objective-C can be either structured or dynamic. Objective-C is a strict superset of C, so if you know C, that's great. Objective-C will just be adding on to that if you're not familiar with C. There is some stuff you need to learn in C to use Objective-C correctly. Also, Objective-C uses automated reference counting, prefix or abbreviated ARC for short, instead of garbage collection. All right, any questions?
Thank you.
All right, thanks.